So this is my Drive to Inquire project featuring the article I chose titled Caffeine. It's written by the World of Scientific Discovery. It was published on April 27th, 2011. So what is caffeine? Caffeine is essentially an alkaloid found in coffee, tea, chocolate, and cola soft drinks. It's been around for over a century. It is one of the world's most used nervous system stimulants. Its molecular formula is C8H10N40. The pure form of caffeine is a solid fleecy white substance. The history of caffeine. The isolation of the substance was found in the early 19th century. During the 1820s, researchers identified agents in tea and chocolate and named them such names as guaranine and theanine. In 1840, T. Martins and D. Berthelot found that these compounds are all identical with caffeine. Caffeine was originally called caffeine or caffeine, but it was later named caffeine. Most of the work leading up to the characterization of the molecular structure was completed by German chemist Emil Fischer. Fischer synthesized the compound from raw materials in 1895, and 2 years later found out the precise formula. From this crappy chart that I made, we can see the amount of caffeine that is in our everyday drink products. Coffee contains the most naturally, since the coffee beans contain caffeine. Here are the effects of moderate caffeine consumptions. I have this picture that shows how caffeine affects the brain, the eyes, and the arteries. We can see that caffeine increases your attention and memory performance. Maybe we should drink some caffeine in schools and students wouldn't be falling asleep so often. It also increases the fluid inside the eye pressure. Decreases the risk of heart disease. It increases physical performance along with muscular recovery and decreases the risk of liver disease. The most important physiological effect of caffeine is that it stimulates nerve cells, mainly in the brain. Caffeine molecules grab hold of brain receptors in nerve cells, causing them to continue the stimulation of those cells. This explains why the common symptoms of caffeine take place, such as wakefulness, awareness, and restlessness, just to name a few. Caffeine affects the nerve tissue in the brain a lot faster than anywhere else in the body. As a result, it could bring about muscle spasms or convulsions, only with very high doses of 10 grams or more of caffeine. That's the same as drinking 70 cups of coffee in a short time. So therefore, death from caffeine overdose is highly unlikely. But I actually have a death by caffeine generator that I'm going to show you guys later on after this PowerPoint. Health effects of caffeine. There are many possible health effects of caffeine that have been expressed for a long time. Recent concerns about its effect focus on mutagenic effects, those that affect a fetus. These mutagenic effects change reproductive genes, producing mutations in further generations. Apparently, scientists have connected high consumptions of caffeine to types of cancer, but such connections are hard to find in the average coffee drinker. Right here is a recent finding that has to do with the mixing of alcohol and caffeine. In 2010, the U.S. Food and Drug Administration found mounting evidence concerning the dangers of alcohol and caffeine together. It showed that people who drank energy drinks weekly were at a higher risk for alcohol dependence. It was also associated with higher blood concentration levels and in return showed higher rates of risky behavior, e.g. driving while impaired. As a result of this finding, caffeine-spiked alcoholic drinks have been taken off the shelves of stores and are now an imposition of the state law restrictions. Here's my information regarding the source citation of my article. I will also include a download to my article if anyone is interested, because the URL is not functioning right anymore. I will now be discussing how I found my article and everything like that. Most people found their article by typing in chemistry-related topics into it, such as mine, caffeine. I didn't find mine this way. What I did was I went to Mr. Leung's Twitter, and he was posting links about article databases, and one of the links was called Gale Group, and it was actually really quite useful. That's where I found my article. It was under the chemistry tab, and on the topics it said caffeine. the reason I chose caffeine was because I've always had an obsession with caffeine since my parents told me that it stunts the growth of people. And this shocked me a little because maybe that's the reason I'm not that tall right now. Anyway, here's some chemistry facts about caffeine. When it's heated, caffeine loses water at 80 degrees Celsius. It changes from a solid to a gas at 178 degrees Celsius. And it melts at 237 degrees Celsius. It is only slightly soluble in water and alcohol, but dissolves readily in chloroform. The water solutions of caffeine are essentially neutral at a pH of 6.9. Here's the death by caffeine generated thingy that I was talking about in my PowerPoint. I'm just going to test it out right now. Select a drink, Coca-Cola Classic. I weigh approximately 110 pounds. And it says I need 218 cans of Coca-Cola to put me down. And the average can of Coca-Cola has 34.5 milligrams of caffeine. Now times that by 218, which is huge. That's 7.5 grams of caffeine that could kill me in a short amount of time. Thanks for watching. That's been my presentation on caffeine, and I hope you like it. Have a Merry Christmas.